On this week's episode of Scaffolds, I talked to Dr. Kelsey Tobin, a postdoctoral researcher in my lab, about a new ambrosia beetle that we're finding attacking apple. Carrick talks to us about leaf blotch diseases, and Anna gives us our State of the State update for the week. Today I'm here with Dr. Kelsey Tobin, who is a postdoctoral researcher in my lab here at Agritech. Hello, Kelsey.
Hey, Monique.
So today we're going to talk about ambrosia beetles. Kelsey is an ambrosia beetle expert, and we have a new species of ambrosia beetle in town, so to speak. So I guess I want to start out with, could you tell us a little bit about how we first discovered that this additional species is attacking apples?
Yeah, so I got to the area in January, and there had been a couple of potted apple trees from last season that we had pulled out and saved because they looked like they were infected with fire blight, but we also noticed ambrosia beetle entry holes at some of the branch junctions on these trees. And so we'd left them out and not put them in cold storage, just left them outside and decided to dissect them one day to see if we could find these beetles and how many beetles were in there. At the time, we were expecting it to be the black stem borer, but when we were dissecting them, we found a couple of adults and a lot of larvae in these trees. And we know that black stem borer overwinters as adults, so finding these larvae were an indication that it was not the black stem borer. And we did some molecular work and got a positive identification from the larvae and also from the adult beetle that we found that it is a new species, Anisandrus maisch.
Thankfully, Kelsey came here having done her entire PhD on this species, so I think that was a lucky happenstance in this case. So my next question for you is, in particular, we know about black stem borer, we know black stem borer attacks apples. What is so different about Anisandrus maisch that may have differing implications for their attacks on apples?
So one thing that is interesting to me is this overwintering as larvae. I think that has some implications for maybe some temperature development that we might want to look into and how broadly this species will be able to establish. If it requires some sort of cold, chilling temperature, maybe its range will be limited by areas that can reach that cold temperature. But yeah, it's kind of a species that's starting to pop up not only in apples, but in other ornamental orchards and plantings throughout the United States. And so I think in the coming year or two, we're going to learn a lot about this species. But yeah, that's where our work is headed.
So maisch is invasive. When did it first get to the United States?
It was first found in a ambrosia beetle survey in, I believe, 2009 in Pennsylvania. And at this point, it's probably been confirmed in 12 or 13 states, mostly in the eastern U.S.
It's also possible, right, that this could have been previously mistaken for black stem borer, right?
Yeah, these two beetles are nearly identical. They do require microscopes to be able to distinguish between the two. Ambrosia beetles in general, 1 to 2 millimeters. And so their features are also very small. Yeah, so that's when I was in Indiana during my PhD, that was the case. Was it had been there for probably longer than we thought, but we'd just been misidentifying it for a number of years.
And in terms of when we see Anisandrus maisch flight, how does that compare to our black stem borer flights?
Over the past couple of years, the black stem borer has had an early spring peak in around May, a large peak, and then followed by a smaller second peak in July. We start to see Anisandrus maisch flying probably like early June, mid-June. But then their flight is more prolonged, where we're getting high weekly captures throughout most of the rest of the summer. So we're still catching upwards of 20 to 30 in each trap still right now in almost August. So I think they have a longer, more protracted flight throughout the season.
I also think in New York, what I've heard generally speaking, talking to growers, is that they think that the ambrosia beetle issue is resolved. And last week I was asked by a consultant and the Palmers at Reality Research to visit this farm in Western New York that had a bunch of fire blight, but also a bunch of ambrosia beetle attacks. And we think that the damage and the decline to the trees is multifactorial, meaning that it could be, the original tree stress happening. It could be the fire blight bringing in the ambrosia beetles, but either way, they're there. And so I brought back a bunch of trees and samples to Kelsey, and we confirmed that yet again, we're finding maish in apple, and this would be so easy to mistake for black stem borer. So I guess the next thing I think we should talk about is, where do we think we are with management? So currently what's happening is, if there's a problem, and like I said, folks say that this is a resolved issue, sort of user error. If you have, bad tiling and flooding in your field, that this is going to solve the ambrosia beetle issue, is to correct those sort of tree stressors. But I will say that when you have an attack, the decline on the trees, especially if they're young and they're newly planted, is going to be extreme, and it's going to be fast. So I think that talking about this as an issue that is over resolved is great for the people that don't have the issue, but the people that have the issue, I think it's quite tragic. So I think, now where we are with management is that there's the idea that you can have a regional trap line and you can kind of track the flights of ambrosia beetles because they're way too difficult to identify on your own. So you could have a trap out, and if you were trained, and maybe that's an idea, something we should do. Maybe we should put on a workshop to train people on ambrosia beetles. But I think that, figuring out where we are with management. So again, like I said, the trapping, peak flight, there is the application of a pyrethroid, but we're still not really sure how this actually affects them, if that actually prevents attacks. Because even if you time it that initial peak flight, if this other species continues to fly and there continues to be stressors, then you may have additional attacks that you're unaware of timing sprays for. So what do you think we can do to innovate in terms of managing these guys? Because once they're in the tree, we don't have a lot of good solutions.
Yeah, that's a great question. So we've been working on this push-pull experiment. These ambrosia beetles are primarily attracted to ethanol, but we're also interested in identifying other compounds that might help us improve our trapping techniques currently. But we also have identified some really strong repellent compounds. They've been repellent in the lab, and also we've started to test those in the field to see if we can essentially just push the beetles away from these commodity plantings. And we have just wrapped up a multi-state experiment using verbenone as the push and ethanol as the pull to lure them into traps and kill them. We have tons of traps and beetle ID that we're still going through, so we don't have any results to report on that currently, but next year on Scaffolds, we'll report those findings. So that's one thing that we've been working on, is just trying to improve the trapping and also try to manipulate where these beetles are actually going instead of attacking the trees. We also know that they feed on fungus and not actually on the tree itself. So we could look into testing some fungicides that might knock back that nutritional symbiote that they feed on, and then they would theoretically not be able to feed and complete their life cycle that way. So that's another avenue that we could look at. Yeah, just trying to identify these behavior modifying compounds and trying to control the populations, mostly with trapping.
Yeah, so that is one approach, is mass trapping if there is an issue or if you have a particular block that keeps getting attacked. We will see what happens with this push-pull. I know Artignello was working on that a bit with this product called Splat before my time, and I'm not sure, he was doing that in potted trees, so not exactly the same as what we were doing in an actual field that was experiencing attacks. So we'll see what the results come out as, but I think this is one of the more difficult pests to manage if you do have a problem. The insecticide recommendations I don't think are clear in a lot of ways because you're spraying to try to time for the flight, and I do think that this is one of those insects that probably was residually controlled by chlorpyrifos or applications of diazinon, but no longer are those products really in our arsenal. So I think that we have a charge ahead of us to try to figure out some additional ways to control these guys. So I want to thank you so much, Kelsey, for being on the podcast today, and hopefully we'll bring you back on again soon with some results.
Yeah, that sounds good. Thank you.
All right, welcome to the next week of Scaffolds. The getting close to the end of the scaffold season. July 27th. We just got a little bit of a month left. Where are we now? Let's talk about a seasonal disease overview. We had high apple scab this year with heavy rainfall in the early pre-bloom part of the season and some a little bit later. High pressure from powdery mildew as well. high humidity from the rainfall, a lot of powdery mildew. Fortunately, the cold, wet weather wasn't as good for fire blight and low risk and low pressure from fire blight with a cold bloom in the sort of immediately cold post bloom. But shortly after that, we still got around in the beginning of June, and we'll talk about that, more high risk scab weather and some weather for other later mid-season fungal diseases as well. Hot weather, heavy rainfall, not enough heat to potentially burn out all the apple scab lesions, and many of the other things could also sneak through as well. And now we're in a period where we're seeing a lot of leaf spots. It's been sort of hot, followed by a storm, which is then cool for a couple of days and then dry. The heat dries things up quickly. We don't have a lot of moisture hanging around. It's hot, storm, cool, dry, hot, storm. And it's sort of that way for most of the month of July. Let's take a quick look. As we look into June, we're moving around at the beginning of June. It almost rained the entire day, with some days as much as a quarter or a third of an inch, moving all the way in through June 10th. It finally ends around June 11th from all the constant rain that we had, and we have a nice dry spell that once again ends around the 18th, and starting maybe even the evening of the 17th, we're moving around with getting almost a quarter of an inch of rain almost every day, all the way through entirely through the end of the month. Yes, there are a couple breaks in the rain as around the 25th and 28th, but it's really not much of a break. And I think all of this wet weather might be the result of some of the seemingly scab that's coming out of nowhere and leaf spots that are showing up. This could be some of the cause of what we're seeing there. Because when we move into July, finally, around the holiday Independence Day, things are looking great. July 1st to the 7th, it's been fairly dry. And then we start to move into the storm period. Stays dry through about July 9th. We have some storms around the 11th and 10th, dropping about an inch of rain that completely goes away later. The wetting event temperatures are still in the high 70s, suggesting that it was very hot before and after. And sometimes hot days followed by quick cool 2 days, followed by more hot days, can do some strange things to apple leaves, as we'll talk about later. In the next weekend through July 15th, pretty good. Just another one of these spike rains with tornadoes and cooling events, and then it pops right back up to heat again as we're moving into our present week, which finally we get a little bit more rain, sort of overcast. It's sort of hot all day long, and the rain comes at sort of the end of the day, maybe even over the night. So with that in mind, let's talk a bit about summer foliar diseases. We've talked about a lot of these: glomerella leaf spot, apple blotch, known as Marsanina, frog eye leaf spot, alternary leaf spot, and maybe even some weird things like necrotic leaf blotch as well. These things will defoliate trees. They'll start to do it around August. Even if you're seeing them now, it's still possible to get a handle on them, or you may have gotten a handle on a lot of them and we're just seeing the results of an earlier season failure. It may not mean that all the leaves fall off your tree in September. Be very careful. Some of them can look very similar, and they can be a little confusing, and we'll go over it. How do you beat these? Typically, you'll get them with your apple scab management programs. The infection times overlap. Scab usually comes in a little bit early, and if you fail to control it, like I did in my test plots, because I want to see scab pressure, in many instances, I won't get the apple blotch or the Marsanina leaf blight or the glomerella leaf spot. These types of things won't show up because apple scab has already taken all the real estate. However, if you do a fantastic job and move back off a little bit as we move into the mid-season, you might start to see some of these things show up. Typically, they're only going to be really bad in organic operations. Yes, I've got organic apples, but I got scab-resistant variety, and the next thing I know, the blotch comes through and takes everything out. Or if you rely too much on multi-site protectant fungicides, they can be great, particularly for these late season leaf diseases, but those single site fungicides are the hammer. Now, some of the other things like Xyram and the EBDCs can be quite good against some of these leaf spots, and as these are curtailed, we might see more problems in the future. Now, let's look at the first one: Marsanina leaf blight, MLB. Been renamed as apple blotch. Classic defoliation in early September. Here's my Jonah Gold apples. All the leaves are on the ground. And if you were to dig through the leaf litter, you would start to see things that look very strange. It's like the leaf is turned yellow and it's made out of rice paper, and someone is hitting it with an ink brush, and it makes these little splotches of sort of inky green, like a watercolor, if you will. And in the very center of these sort of blotches or Rorschach ink blotch looking leaves that are normally sort of chlorotic and yellow yellow on the outside, you can see the tiny fruiting bodies of the pathogen when they start to develop. Some leaves up on, even on trees on the way home, you can, around your house, you can sort of find these things. Wild apples and wild crabs will have that as well. And that's what I usually like to do to sort of monitor the position or sort of development of this disease when I can't get out to the field. It's been a little less this year, but it can even cause spots on fruit. Last year, when I had low scab pressure of a lot of heavier rains at the end of the season, my trees that had defoliated with apple blotch MLB had spots all over the fruits as well, and they're pretty much gone. All the leaves are sort of gone around those apples and on the ground, just covered in the Marsanina. Now, what are some of the other weird ones that can show up as well? In our area, we can have the frog eye leaf spot. Small circular spots that kind of have concentric rings in it. It's kind of look like weird herbicide damage or a weird pesticide injury caused by a fungus called Botrysphaeria. This fungus loves to live and sporulate and cankers in thinning mummies. You might see more frog eye leaf spot in varieties that have the little thinning mummies. That can be a little shriveled up fruit that was killed during apple thinning, and it's just colonized with this wood decay fungus. It's weakly pathogenic. It's not going to be as devastatingly defoliate the tree, but if things are bad in wet summers, it can cause really awful fruit rots, and it can cause cankers as well, which can kill your tree, but not as quickly as things like fire blight. You might confuse it with a nectria canker. It might be doing the killing while the nectria gets very bright and colorful and orange and showy. And these can cause fruit rots if we get into the fall. Sometimes you can see the thinning mummies around a fruit that is loaded with this sort of black rot. And this is all beginning to form fruiting bodies and on the surface of fruit. So little tiny things that look like black specks are going to be your key to fruiting bodies. Can it show up with other things as well? Sometimes it's hard to tell if some of this stuff, you can have frog eye leaf spot and apple blotch. And I was talking with my colleague, Sarah Villani at NC State, who is an expert on glomerella leaf spots, Marsanina leaf blight, apple blotch, and alternaria, and all the other weird things that show up in North Carolina. And she's seen frog eye with all the others and alternaria with all the others. And sometimes you can get a little bit of both. They don't outcompete each other as easily as the scab and the others. Frog eye, you'll see those nice concentric circles, and sometimes they can get yellow and chlorotic depending on the variety. But what we're not seeing in the frog eye in that case is a lot of little tiny specks of the fruiting bodies that make the spores deep inside the lesions. You can take a look at that. Now, one thing I hope we don't have, but it's starting to look like it could be showing up, is the glomerella leaf spot. And as we're getting weird leaves sent in and pictures of leaves sent in from growers, it's important to kind of look at this as well. Trees can look great in July and then completely defoliate in September, putting everything on the ground, just like Marsanina leaf blight or apple blotch situations as well. Now, this is going to be a little bit different. You might see things that look like this in your orchard. It's going to start out with small purple lesions. And in my discussions with Sarah, it's like if you don't see the small developing purple lesions, in addition to the larger brown necrotic central lesions, you might not have glomerella leaf spot. The characteristics are seeing a mix of the developing ones and larger brown necrotic things. The other thing that you're going to see with this is numerous little concentric rings within the large blotchy lesions. They're still somewhat confined by the major leaf veins as well. And they'll have the little concentric rings and the small purple ones. And so as I've been evaluating samples, I've been looking for small purple lesions. I've been looking for concentric rings with inside the blotchy lesion. As this gets bigger and more developed, the rest of the leaf will turn from beautiful green to a pale yellow and chlorotic, and it'll just fall off at those particular points as well. And can it cause symptoms on fruit? It looks a lot like the apple blotch, Marsanina leaf blight symptoms on fruit. At first, little tiny spots or a little sunken lesion with a dot or a fruiting body in it. And as things get bigger, it can kind of almost look like herbicide injury on fruits where things get a little more sunken, just like the MLB. And unlike the MLB, the lesions can get quite large and begin to look more like a black rot or almost more like an anthracnose or bitter rot lesion as well. If they get really advanced, they can spread and a little more aggressive. Now, one of the other things that I've been concerned about recently, given the weather and other things, and some of the strange pictures that we're seeing, is necrotic leaf blotch. Now, what is this nonsense? It looks a lot like the glomerella. It's got large, irregular necrotic lesions delimited by veins, and the leaf becomes necrotic. It will be sort of blotched and big. We don't see the fine concentric circles with this, and then sometimes we don't see the little tiny purple lesions. Now, it doesn't mean things that like a little bit of frog eye can't show up in these areas and be a little spot to confuse you, and then sometimes it does look like there might be some concentric rings. If this necrotic leaf blotch is the case, it can be very rapid. It's a mid-season disease that shows up in 12 to 24 hours. It can be like, where did this come from? And these affected leaves can defoliate in about 4 to 7 days. Now, we don't know if we're seeing it, but when this thing does show up, it's during a cool, rainy period that was preceded by very hot summer days, such as all the tornadoes weather, and we have big thunderstorms. Gives us a couple days of cold and heats back up. More storms, cold, heats back up. This can kind of happen. Now, typically, this is a disease of golden parented apples, but sometimes when you get sent pictures of leaves and they're covered in cool water, you think, hey, these are probably taken after one of these rain events, cold snap type situations. Does make you wonder, how does this disease occur? It's not pathogenic necessarily. It's sort of an abiotic physiological problem. Symptoms are made worse by gibberellins. And if you want to manage this, can be managed quite effectively by using EBDCs after petal fall, which pushes our window for things like mancozeb, but something like Xyram could be able to manage this. And that sort of brings the question, since we just recently lost Xyram and we're having these hot, cold snaps, are we starting to see necrotic leaf blotch? Or maybe the impact of not being able to have Xyram in our summer programs by getting rid of that zinc in the summer or mid-season that would let some of this stuff show up. So food for thought as we think about it. And soon it'll be time to start talking about pre-harvest fruit rots. I've been sort of holding off on those all season. I touched on a little bit of them today with the glomerella and the Brachysphaeria, but that's coming up. All right, see you in a week.
And now for the state of the state, your weekly update of phenology and degree accumulations for the major fruit-producing regions of the state. As always, I'm Anna Wallace with the New York State IPM program at Cornell, and I'll be sharing information aggregated from the regional specialists and my own observations. Last week, we had more heat and humidity across the state, with highs in the 80s in the Hudson Valley and the Capital Region, slightly cooler in the Lake Ontario region and the Champlain Valley, with highs in the upper 70s and low 80s. Overnight low temperatures were consistently in the 50s and 60s across the state. We're hoping to have some more cool overnight low temperatures over the next couple of weeks to help with fruit color. We've received considerable rainfall across the state over the past couple of weeks, which is good news because the rainfall has replenished soil moisture in most places. This is in stark contrast to other parts of the Northeast, including Virginia and West Virginia, which is currently under a severe drought, and parts of Vermont and other parts of New England that have had excessive rainfall over the past few weeks. So most of New York is in a good place with precipitation at this time. We had a little bit more rainfall early last week, although surprisingly little accumulation, with less than a quarter of an inch recorded in most NEWA weather station locations. A few isolated locations had up to 3/4 of an inch of rain. Looking at the forecast for the rest of the week and into the next couple of weeks, the 6 to 10 day outlook from the NOAA Climate Prediction Center is still forecasting above average temperatures, but near normal precipitation. And the 8 to 14 day outlook is slightly different, with northern parts of the state, the Champlain Valley, Franklin, and St. Lawrence counties, near normal conditions for temperatures. The Lake Ontario and Capital Region are expected to be just slightly above normal conditions, and in the Hudson Valley, we're expected to have above average temperatures. Across the state, we're expected to have slightly above average precipitation. In the longer-term forecast, from the middle of July through the middle of August, the NOAA Climate Prediction Center is again expecting hotter than average temperatures. Looking at phenology across the state now, most apples are at terminal bud set or approaching terminal bud set. We've said this for the past couple of weeks, but we're still seeing some new growth in different places and varieties, especially with all of the rainfall. Fruit is continuing to color and size really well as we approach harvest, and we're expecting an early harvest. This is no surprise to anyone, but we are encouraging people to get out and be looking at fruit sooner than you would normally. As we approach harvest, various predictions are being made about harvest dates for
for this season. Craig Kalke in the Lake Ontario region with the Lake Ontario Fruit Team published some predictions and degree day accumulation comparisons for 2024 as compared to other seasons and historical averages. And Craig's predictions indicate we're 10 to 12 days ahead of averages in most of the Lake Ontario region. Using degree day accumulations from the Climate Smart Farming tool at Cornell, which provides seasonal degree day accumulations as well as 15-year averages and 30-year normals, we are about 7 to 10 days ahead of average across most of the state. So needless to say, we are expecting an early harvest, and we're encouraging people to get out and look at fruit earlier than later. In the Hudson Valley, stone fruit is now picking with lots of peaches and plums coming into harvest. Apples are continuing to color and size very well. The very first apples in the lower Hudson Valley with varieties like Pristine and other early varieties are just beginning harvest this week. In other parts of the state, in the Lake Ontario region and the Capital region, as well as the Champlain Valley, things are looking about a week behind that, if not a little bit more in cooler locations. Now looking at some upcoming pest events. Apple maggot is the focus of many pest management programs at this time. We are continuing to catch apple maggot across the state with heavy captures in unmanaged or abandoned locations. We did see some increase in captures last week in both the Lake Ontario region and in the Hudson Valley. Trap captures continue to increase in many places where we know there is a high population and significant pressure. But in other locations, we don't have any trap captures at all, or we have very low trap captures that have been consistent over the past few weeks. So it's important to continue paying attention to your location. Remembering at this part of the season, we are using red spheres coated with sticky tanglefoot, and those traps are capturing the ovipositing females. The threshold for those traps, again, is 5 per baited trap, which would be baited with an ammonium sulfate or a pear or apple essence. And for unbaited traps, the threshold is 1 to 2 per trap. Codling moth second generation larvae are also a pest we're thinking about right now. In the Hudson Valley, the second generation larval emergence is happening at this time, and so this is a good time for insecticide applications targeting larvae. In the Lake Ontario and Capital region, we've seen an uptick in trap captures indicating the second generation emergence, and the model is predicting that the larvae will be emerging at the end of this week or early next week. So that would be a good time for an insecticide applications targeting those guys. And in the Champlain Valley, we're also seeing an uptick in moths this week in traps. And so perhaps at the end of next week would be a good timing for targeting the larvae of the second generation there. We are getting a number of reports of internal Lepidopteran feeding across the state this year. So this can be codling moth. It's easier to identify that insect because it prefers to feed on the seeds. So codling moth will tunnel directly to the center of the fruit and feed on the seeds, which are rich in nitrogen and a good nutrition source for that insect. You can also find oriental fruit moth and lesser appleworm tunneling into the fruit, although those insects may not feed directly on the seeds, but just tunnel toward the center of the fruit. It's important to be identifying which pest is affecting your fruit if you do have any damage. That way you can be targeting your insecticides for next season to the appropriate pest. During this second generation larvae emergence, when we're targeting insecticides, remember to be rotating chemistries for the second generation compared to what you use for the first generation. This insect can be endemic to the orchard, so it's important that we change up the things that we're using against the insect so we don't develop insecticide resistance in the population. Oblique-banded leaf roller trap captures continue to be very low. No trap captures this week in a number of locations and very low trap captures in other locations. So right now is not a good time to be putting any insecticides out targeting this insect for management. We continue to see European red mites and two-spotted spider mites in isolated locations. This can cause bronzing and feeding on the leaves, which is caused by the rasping of these insects feeding on the chlorophyll. We're seeing a little bit more activity of aphids at this time. Often we have a flush of green aphids at this part of the season, more likely in a dry year when these insects are looking for a moisture source. We're also continuing to see woolly apple aphid active in many locations, although management over the past couple of weeks has suppressed populations quite a bit in many locations. Stink bugs continue to be active. We are in the second generation of many stink bugs, including brown marmorated stink bugs. So those nymphs are now moving into fruit and starting to feed on fruit. Often they jump over from an adjacent crop like soybean or corn, so be paying attention to that in your area. If you're using a trap to be monitoring for this insect, we recommend that you're placing it on the edge of the orchard so you know when it's moving in. If you're using a tedder trap, a black pyramid trap, the threshold is 10 per trap per week. And if you're using a clear sticky panel, these have a similar expected detection of the first insects, but they tend to be lower counts. And so we recommend 3 to 4 per sticky panel per week. We've seen very little feeding in apples at this point in the season, just a little bit in isolated locations. We've also seen a little bit of feeding on peaches, which can show up as cat-facing or dimples in the fruit, although this can be caused by other plant bugs as well. Moving into diseases, just a reminder, we continue to see scab lesions popping up in some unexpected places this year, so stay on top of that and look for secondary infections that could continue to be affecting leaves and fruit at this point in the season. We continue to see powdery mildew. We've also seen a little bit less of this after all the rain. Powdery mildew can't survive in freestanding water, so we know that that's been suppressed a little bit, especially in locations that have had high rainfall over the past couple of weeks. But it could take off again in the really hot, humid conditions that we're expected to have over the next couple of weeks. At this point in the middle of the summer, we know that sooty blotch and fly speck and fruit rots are the focus of disease management programs. Look for bitter rot and Botrosphaeria. So bitter rot you'd be able to recognize by orange fruiting bodies and concentric circles on the fruit in that rot circle. You can cut the fruit in half through that lesion and see a V shape if it's bitter rot as well. We're seeing quite a bit of frog eye leaf spot or black rot or Botrosphaeria in some locations, and those lesions look like defined circles, brown, that are depressed on the leaf lesions. And then in the center of those lesions, you can see black fruiting bodies. And so that's a way to identify frog eye leaf spot or Botrosphaeria. We're also starting to get more reports of yellow leaf spotting that could be caused by Marsanina, Glomerella, and necrotic leaf blotch. So if you're interested in getting help with diagnosing those, please send us some pictures. We'd be happy to help. Carrick also did a great review of these disorders and diseases in last week's podcast, so we encourage you to review that. And he has a great video on his blog and website that you can use to help you diagnose any problems that you may be having in your orchard. We also start to see more decline at this point in the season, which there are lots of reasons for tree decline to happen and collapse. We often see it around this time as trees are approaching harvest and trying to support the crop, in addition to whatever other stresses that they're under. This could be related to cold damage, it could be related to moisture, nutrition, or some kind of pest complex. Dr. Jason Londo and his student Ken at Cornell are doing some work to try to characterize decline in apple orchards across the state. So we are asking you to report any decline that you may have to an extension specialist, or you can do it through the anonymous survey that is available through many of the regional newsletters, and also a link is included in the show notes of this podcast. And now, here are the current degree days in the major fruit-producing regions of the state. Throughout the season, we've been aligning this information with previous work done by Art and Yellow related to Macintosh phenology and degree days base 43 Fahrenheit. Current degree day accumulation from January 1st to July 29th included in Geneva, 2,637, in Highland at the Hudson Valley Research Lab, 2,844, in Clifton Park, 2,684, in Peru, 2,349, Medina and Inland Site, 2,548, Appleton North, in Lake Site, 2,403, Fairville, an inland site, 2,510, and Williamson, a lake site, 2,582. As always, this table of degree day accumulations is in the show notes, as well as a table of upcoming pest events taken from Table 714 from the Cornell Guidelines. That's all for this week, and good luck until next week.